Dear friends, this video is Chapter 2 of Basic Skill of Diesel Engine Operation and Maintenance. Useful to construction and mining professional and technicians working in construction industry. Here we will discuss about A. Fuel systems in diesel engines. B. Common rail, direct injection, and indirect injection. C. Air handling and turbocharging. D. Lubrication systems. E. Cooling systems and engine control units, ECUs. We'll now begin discussing a different topic. A. Fuel systems in diesel engines. Fuel systems in diesel engines are responsible for delivering a controlled amount of diesel fuel to the engine's combustion chambers, where it is mixed with air and ignited. Proper fuel delivery and atomization are critical for efficient and clean combustion. There are several types of fuel systems used in diesel engines, including 1. Direct injection (DI) fuel system. 1A. Direct injection is the most common fuel system in modern diesel engines. 1B. In a direct injection system, fuel is injected directly into the combustion chamber at high pressure. 1C. This system provides precise control over fuel delivery, leading to better combustion efficiency and reduced emissions. 1D. It often employs common rail technology, where a common high-pressure fuel rail supplies fuel to multiple injectors. 2. Indirect injection, IDI, fuel system. 2A. Indirect injection systems were common in older diesel engines but are less prevalent today. 2B. In an IDI system, fuel is injected into a pre-combustion chamber or swirl chamber instead of directly into the main combustion chamber. 2C. The fuel vaporizes and mixes with air in the pre-combustion chamber before entering the main combustion chamber. 2D. IDI systems are known for their smooth and quiet operation but are generally less fuel efficient than direct injection systems. 3. Unit injector, UI, and unit pump, UP, systems. 3A. These systems combine the fuel injection pump and injector into a single unit for each cylinder. 3B. Unit injector systems, UI, use a separate high-pressure pump for each cylinder, while unit pump systems, UP, use a single high-pressure pump for multiple cylinders. They offer precise control over fuel injection and are commonly used in medium and heavy-duty diesel engines. 4. Common rail fuel system. 4A. The common rail system is a type of direct injection system where a common high-pressure fuel rail supplies fuel to all injectors. 4B. Each injector is electronically controlled and can deliver fuel independently, allowing for precise timing and multiple injection events, which improve combustion efficiency and emissions control. Common rail systems are used in a wide range of diesel engines, including automotive, industrial, and marine applications. 5. Distributor injection pump, distributor-type fuel system. 5A. Distributor injection pumps are typically used in older diesel engines and some medium-duty applications. 5B. They distribute fuel to individual injectors through a rotating distributor rotor. 5C. While less precise than common rail systems, they are reliable and can be mechanically controlled. 6. Inline injection pump. 6A. Inline injection pumps are often used in medium and heavy-duty diesel engines. 6B. They consist of a single, inline pump that pressurizes fuel and distributes it to individual injectors. 6C. Inline injection pumps can be mechanically or electronically controlled. 7. Electronic fuel injection, EFI. 7A. Many modern diesel engines use electronic control systems to precisely control fuel delivery and optimize combustion. 7B. Electronic systems monitor various engine parameters such as engine speed, load, and temperature to adjust fuel injection timing and quantity in real time. 7C. This improves fuel efficiency, reduces emissions, and enhances engine performance. Fuel systems in diesel engines play a crucial role in achieving efficient combustion, power output, and emissions control. The choice of fuel system depends on the engine's design, intended application, and emission regulations. B. Common rail, direct injection, and indirect injection. Common rail, direct injection, and indirect injection are three different fuel injection methods used in diesel engines. Each method has its own characteristics and advantages. Here's an overview of these fuel injection systems. 1A. Common rail injection. How it works. In a common rail system, a high-pressure fuel rail stores and supplies pressurized diesel fuel to multiple fuel injectors. Each injector is electronically controlled and can deliver precise amounts of fuel independently. Advantages. Precise control. Common rail systems offer exceptional control over fuel delivery, including injection timing and quantity, leading to improved combustion efficiency and reduced emissions. Reduced noise and vibration. The ability to control fuel delivery precisely helps reduce engine noise and vibration. Multiple injection events. Common rail systems can execute multiple injection events during each combustion cycle, further enhancing combustion quality. Applications. Common rail injection systems are widely used in modern diesel engines, including passenger cars, trucks, industrial equipment, and marine engines. 1B. Direct injection, DI. How it works. In a direct injection system, diesel fuel is injected directly into the combustion chamber, where it mixes with compressed air and ignites spontaneously due to the high pressure and temperature. The injectors are typically located in the cylinder head. Advantages. Efficient combustion. Direct injection systems provide excellent air-fuel mixing and efficient combustion, leading to higher fuel efficiency and power output. Lower emissions. The precise control over fuel delivery helps reduce emissions of nitrogen oxides, NOx, and particulate matter, PM. Applications. Direct injection is commonly used in modern diesel engines for passenger cars, trucks, buses, and some industrial and agricultural machinery. 1C. Indirect injection, IDI. How it works. Indirect injection systems, also known as pre-combustion chamber or swirl chamber systems, involve injecting diesel fuel into a separate pre-combustion chamber adjacent to the main combustion chamber. The fuel vaporizes and mixes with air before entering the main chamber. Advantages. Smooth operation. IDI systems are known for their smooth and quiet operation due to the controlled ignition process. Durability, they are robust and can withstand harsh operating conditions. Disadvantages. Lower efficiency. IDI systems are less fuel efficient than direct injection due to the less efficient air-fuel mixing process. Higher emissions. They tend to produce higher levels of emissions, particularly NOx. Applications. Indirect injection systems were more common in older diesel engines and are less prevalent in modern engines. They may still be found in some medium and heavy-duty applications. In summary, common rail, direct injection, and indirect injection are different methods of delivering fuel to diesel engines. Common rail systems offer precise control and are widely used in modern diesel engines. Direct injection systems are known for their efficiency and emissions benefits. Indirect injection systems, while durable and smooth running, are less efficient and are less common in modern diesel engines. The choice of injection method depends on factors like engine design, emissions regulations, and intended application. C. Air handling and turbocharging of diesel engine. Air handling and turbocharging are crucial aspects of diesel engine operation that significantly impact performance, efficiency, and power output. These systems ensure that the engine receives the right amount of air for efficient combustion. Here's an overview of air handling and turbocharging in diesel engines. 1. Air handling. Air handling refers to the process of managing the flow and quality of air into the diesel engine's combustion chambers. Proper air handling is essential for achieving efficient and clean combustion. Key components and considerations in air handling include 1A. Air filter. The air filter removes dust, debris, and contaminants from the incoming air, ensuring that only clean air enters the engine. A clean air supply is critical to prevent engine damage and maintain efficiency. 1b. Intake manifold. The intake manifold distributes air evenly to all cylinders of the engine. It is designed to optimize airflow and achieve a balanced air-to-fuel ratio. 1c. Throttle valve. Some diesel engines have a throttle valve, similar to gasoline engines, to control the amount of air entering the engine. However, many diesel engines use a different method called throttle-less or load control to regulate power output by adjusting the amount of fuel injected, rather than restricting airflow. 2. Turbocharging. Turbocharging is a technology used in many diesel engines to increase their power output and efficiency by forcing more air into the combustion chamber. Here's how turbocharging works. A turbocharger consists of two main components, the turbine and the compressor. It is typically mounted on the exhaust side of the engine. 2a. The exhaust gases leaving the engine spin the turbine. 2b. The spinning turbine is connected to a shaft, which also drives the compressor on the intake side. 2c. The compressor draws in and compresses incoming air, increasing its pressure and density. 2d. The pressurized air is then delivered to the engine's intake manifold at a higher density than atmospheric air. Advantages of turbocharging. Increased power. Turbocharging allows for a significant increase in engine power output without increasing engine size. Improved efficiency. By compressing the air, turbocharging improves the engine's volumetric efficiency, which leads to better fuel combustion and efficiency. High-altitude performance. Turbocharged engines maintain their power output at high altitudes where atmospheric pressure is lower. 3. Intercooler. In many turbocharged diesel engines, an intercooler is used to cool the compressed air before it enters the combustion chamber. Cooling the air increases its density, further enhancing combustion efficiency. 4. Variable geometry turbochargers, VGT. Some modern diesel engines employ VGT technology, which allows the turbocharger's vanes or nozzles to change position, adjusting the airflow and boost pressure based on engine load and speed. This improves responsiveness and efficiency across a wide range of operating conditions. 5. Twin turbocharging. In some high-performance diesel engines, two turbochargers of different sizes are used in series, sequential turbocharging, or in parallel twin turbocharging, to optimize power delivery across the entire RPM range. In summary, air handling and turbocharging are essential aspects of diesel engine design and operation. They ensure that the engine receives the necessary quantity of air to achieve efficient combustion and produce the desired power output. Turbocharging, in particular, is a key technology for increasing engine performance and efficiency in many diesel applications. D. Lubrication systems of diesel engine. The lubrication system in a diesel engine is crucial for reducing friction and wear between moving parts, dissipating heat, and ensuring the engine operates smoothly and efficiently. It provides a continuous supply of oil to various engine components that require lubrication. Here's an overview of the lubrication system in a diesel engine. 1. Engine oil reservoir, oil pan. 1a. The oil reservoir, often referred to as the oil pan, is located at the bottom of the engine and holds the engine oil. 1b. Is designed to maintain a certain oil level to ensure a constant supply of oil to the engine's components. 2. Oil pump. 2a. The oil pump is responsible for drawing oil from the oil pan and pressurizing it to ensure adequate oil flow throughout the engine. 2b. It can be either gear-driven or chain-driven and is typically located in the engine's lower section. 3. Oil filter. 3a. The oil filter is an essential component that removes contaminants, such as dirt, metal particles, and impurities, from the engine oil. 3b. Clean oil is vital for preventing damage to engine components and maintaining engine efficiency. 4. Oil passages and galleries. 4a. Oil passages and galleries are built into the engine block and cylinder head to distribute oil to various engine components. 4b. These passages route the pressurized oil to critical areas that require lubrication, such as bearings, camshafts, crankshafts, and valve trains. 5. Main bearings and crankshaft journals. 5a. The main bearings provide lubrication to the engine's crankshaft, allowing it to rotate smoothly. 5b. Oil is supplied to the main bearings via passages in the engine block. 6. Connecting rod bearings. 6a. Connecting rod bearings provide lubrication to the connection points between the connecting rods and the crankshaft. 6b. Like the main bearings, they receive oil through passages in the engine block. 7. Camshaft and valve train components. 7a. The camshaft, valve lifters, pushrods in pushrod engines, and valve stems require lubrication to reduce friction. 7b. Oil is delivered to these components through dedicated passages in the cylinder head. 8. Piston rings and cylinder walls. 8a. Piston rings and cylinder walls need lubrication to reduce friction and prevent excessive wear. 8b. As the pistons move up and down the cylinder walls, they splash oil onto the cylinder walls, providing lubrication. 9. Turbocharger bearings, if equipped. 9a. In turbocharged diesel engines, the turbocharger's bearings require lubrication. 9b. Oil is supplied to the turbocharger through dedicated oil lines. 10. Oil cooler, optional. 10a. Some diesel engines feature an oil cooler to regulate oil temperature by dissipating excess heat. 10b. Cooler oil helps maintain engine efficiency and prevents oil degradation. 11. Oil pressure gauge/sensor. 11a. An oil pressure gauge or sensor monitors the engine's oil pressure. 11b. Low oil pressure can indicate a problem with the lubrication system or insufficient oil supply. Proper maintenance of the lubrication system, including regular oil changes and filter replacement, is essential to ensure the longevity and reliable performance of a diesel engine. It's also crucial to use the correct type and grade of engine oil recommended by the manufacturer to maintain optimal lubrication and protect against wear and corrosion. Cooling systems and engine control units of diesel engine. Cooling systems and engine control units, ECUs, are critical components in diesel engines. They work together to regulate engine temperature, optimize performance, and ensure efficient operation. Here's an overview of cooling systems and ECUs in diesel engines. Cooling systems. 1. Radiator. Diesel engines generate a significant amount of heat during operation. The radiator is a heat exchanger that transfers heat away from the engine coolant using a combination of convection and radiation. Air flowing over the radiator's fins dissipates the heat. 2. Coolant. A mixture of water and antifreeze, usually ethylene glycol, circulates through the engine to absorb and carry away excess heat. Coolant also prevents freezing in cold temperatures and inhibits corrosion. 3. Water pump. The water pump is responsible for circulating the coolant through the engine and radiator. It is typically belt-driven and ensures a continuous flow of coolant. 4. Thermostat. The thermostat regulates the flow of coolant by controlling the opening and closing of a valve. It helps maintain the engine at an optimal operating temperature by allowing coolant to circulate through the radiator once the engine reaches a specific temperature. 5. Cooling fans. Cooling fans are used to increase airflow through the radiator when the natural airflow, due to vehicle speed, is insufficient. They can be mechanically driven or electrically controlled, depending on the vehicle's design. 6. Expansion tank, overflow tank. This reservoir provides space for coolant expansion as it heats up. It also allows coolant to be drawn back into the system as the engine cools down. 7. Hoses and pipes. A network of hoses and pipes carries coolant between the engine, radiator, water pump, and other components in the cooling system. 8. Thermal management system. Some modern diesel engines have advanced thermal management systems that allow for precise control of coolant flow and temperature. This can help improve engine efficiency and reduce emissions. Engine control units, ECUs. 1. Engine Control Module, ECM. The ECM, also known as the ECU, is the brain of the diesel engine. It monitors various sensors throughout the engine and vehicle to make real-time adjustments to optimize engine performance, emissions, and fuel efficiency. 2. Sensors. Diesel engines are equipped with a range of sensors, including those for measuring engine temperature, airflow, exhaust gas composition, crankshaft position, and more. These sensors provide data to the ECM for decision-making. 3. Fuel injection control. The ECU controls the timing and quantity of fuel injection. It ensures that the correct amount of fuel is delivered to each cylinder at the right time for efficient combustion. 4. Turbocharger control. If the engine is equipped with a turbocharger, the ECU manages its operation, adjusting boost pressure to optimize power and efficiency. 5. Emissions control. The ECU plays a crucial role in managing emissions by adjusting fuel injection, exhaust gas recirculation, EGR, and other parameters to meet emission standards. 6. Diagnostic and error handling. The ECU continuously monitors the engine's performance and will trigger error codes, check engine light, if it detects a problem. These codes can be read with diagnostic tools to identify issues. 7. Engine protection. The ECU also has safety features to protect the engine from overheating, excessive RPM, or other conditions that could cause damage. It may limit power or shut down the engine if necessary. 8. Adaptive features. Some ECUs have adaptive learning capabilities that allow them to adjust to a driver's habits and changing operating conditions to optimize performance and efficiency. Cooling systems and ECUs work together to ensure the engine operates within its optimal temperature range and delivers the desired performance while meeting emissions and efficiency standards. These systems are essential for the reliable and efficient operation of diesel engines in various applications. Friends, we have explained in brief about basic skill of diesel engine operation and maintenance. We request all to mention your view and requirement in comments section of YouTube video. Also like and share to your friend. Also subscribe our YouTube channel Infomechanizer. This is 100% free.